1. Interpreting and solving word problems that involve quadratic equations. A garden measuring 12 meters by 60 meters is to have a pedestrian pathway that is W meters wide installed all the way around it, increasing the total area to 285 meters square. What is the width of the pathway? Let's make a plan. Let's make a plan that has 3 steps. First, we are going to make sense of the situation. Second, we're going to analyze the relationship between the quantities. And third, we are going to solve the equations. We will expand on these ideas. So let's follow the plan. Let's make sense of the situation. Our strategy is going to be to sketch a diagram. Let's make a diagram of the garden and let's interpret the word problems as much as we can into a diagram. Did you draw a rectangle? If you did, how did you know to draw a rectangle? How do you infer that the diagram is in a rectangular shape? You probably know that it's a rectangular shape because of the dimensions. 12 meters by 60 meters suggests that it's in rectangular shape. We can infer that it's going to be rectangular. We could add some grass just to be creative. Feel free to be creative with your diagram. And now we can also add the dimensions. 12 meters wide and 60 meters of length. And now let's add the pathway. The pathway that goes all the way around the garden. The word problem states that the pathway is W in width. So we can go ahead and add W meter in width to the diagram. So it begins to look a lot more complete. Going back to our plan, now we are ready for our second step, understanding the relationship between the quantities. Our strategy is going to be to establish an equation. Let's see how we can do that. It is a good idea to go back to our word problem, to the statement, and remember what are we being asked to do. We're being asked to find the width of the pathway. Let's bear that in mind in order to understand the relationship between the quantities. Let's analyze the length. The length we start with 16 meters. But to that we have to add the width of the pathway, which is W. However, because the pathway goes all the way around, we have to add W twice. So we get W plus 16 plus W is the length of the garden, of the rectangle. We can simplify this as 2W plus 16. That will be our representation of the length. That would be the quantity that represents the length of the rectangle. Now, let's move our attention to the width of the garden. We start with 12 meters, but again, to those 12 meters we have to add the width of the pathway, which is represented by W. So because the pathway goes all the way around, we have to add it twice. So we have W plus 12 plus W which can be um, further simplified as 2w plus 12. Now 2w plus 12 is what it's going to represent, is the quantity that is going to represent the width of the garden. And now that we have established the quantity for the width and the length of the rectangle, we can bring our attention to the total area. The total area of the rectangle is 285 meters square. That is going to be important in establishing our equation. Now, because we know that the area of a rectangle is calculated by multiplying the length times the width, and because we know the quantities that represent each one of those dimensions, we can establish the equation as 2w plus 16, which is the length, multiplied by 2w plus 12, which is the width, equal 285. We can establish this equation. It comes directly from the word problem. It comes from our analyzing the quantities of the word problem. Now we can move to our third step of the plan. Now we're going to solve the equation. Now let's work on solving this equation. Solving this equation is going to call on procedure knowledge. This is where all the knowledge on how to solve equations, how to handle symbolic representations algebraically comes handy. And you already have experience doing this. So maybe this is a good point to pause the video and try to do it on your own, and then resume the video just to check your answer. Now let's move forward and let's solve this equation. We begin with the length multiplied by the width equal to the area. That is 2w plus 16 multiplied by 2w plus 12 equal to 285. Now, when we multiply all the terms of the first binomial by all the terms of the second binomial, we get 4w squared plus 32w plus 24w plus 192 equal to 285. Now, of course, we can proceed to add up the terms that have equal variables and equal exponents, and we get 4w squared plus 56w plus 192 equals to 285. Now, in order to solve this equation, we can make this equation equal to 0 so that we can use factoring. Let's do that. When we bring the equation, when we make the equation equal to 0, we get 4w squared plus 56w minus 93 equal to 0. Now, the advantage of making the equation equal to 0 is that now we can factor the trinomial that is on the left. And when we factor this trinomial, we get 2w plus 31 multiplied by 2w minus 3 equal to 0. Now we can apply the zero property that tells us that when two quantities are being multiplied and you get a product of 0, we can infer that one of them is 0 or both of them are 0. If 2w plus 31 is equal to 0, we get that w is equal to 31 half, negative 31 half. On the other side, on the other hand, If W, on the other hand, if 2W minus 3 is equal to 0, then we get that W is equal to 3/2. Now, because we're talking about area and about the dimensions of the garden, we're talking about distance. And when we are talking about distance, in the context of distance, only positive response makes sense. Only positive results can be used in the contextualization of this problem. This is because distance is always positive.